and I'm going to enable transcript. And obviously I forgot. Okay, here, enable. Okay, I think this should be working. Okay. So today, as I was saying, the school is about artificial intelligence and AI. I guess I forgot to mention one more thing, so I'm going to do it right now and just save, to the recording. Doesn't matter. But yesterday I didn't tell you exactly the truth about the times of the summer school. So this the first week. We're very excited to have students from last year present their project, and for reasons that are unclear, I think due to time zones and all kinds of making it available to them, most of the presentations of those students are in the afternoon in Eastern time. So the first presentation will be on Wednesday, so tomorrow, and it will be by 4 students that got a micro grant, and it's at 1 p.m. Eastern time. And then we have another presentation on Thursday, and then on Friday we have actually 2 presentations. So, but one of them is at 11. So please stick around, ask questions. These are just like you, students that were part of this summer school, and in general, many of them are students who are getting into science of science and maybe are going through the same questions or struggles that you have about entering and participating in this very exciting field. All right, I'm gonna close this. Okay, so today we're going to review AI and machine learning, and the basic idea is that we'll cover very briefly numpy, pandas, and matplotlib, some basic math notation, ideas behind statistical learning, and these are all general things that could apply to anything. And again, scikit-learn, well, not again, but I guess scikit-learn is also a tool that could be applied to anything. In general, I mean, all of these things could be applied to any field. But I will try to introduce some data sets that are related to science of science, like citation data sets and things like that. Now, this notebook is the first notebook of the day 2 of the lectures. So if you go to your space, you should see it there. And then we're going to start next with this notebook, which has the slides for numpy and matplotlib. All right, so I'm going to zoom out here. Oops. Okay, so there is, again, no way that I can go through all of these materials in one day. So these are pointers to places that I believe are good quality and generally introductory for the topic. And this course is a very popular and really like an amazing resource for you to learn about linear algebra. Calculus, the same. There is a free course from MIT, OpenCourseWare. For probability, I suggest this book. The first chapter is not a free book, but I hope it's available somewhere in your library. And for programming, there is a book by Jake Vanderplas. He runs also visualization libraries. And this book is free, so it's Python Data Science Handbook. And this last book, Statistical Learning, is also free. So go there. So this is the latest book, and it's a very, I guess this one is a more introductory book for the topic. I've used all these books in courses that I teach, or I guess I used to teach in Syracuse University to students. I think that that are in similar situation to many of you that are never experienced statistical learning. Some of them didn't even have calculus. Some of them program very little, but they were able to to take advantage of these resources and learn. And then by the end of the semester, of course, they were able to run analysis and discuss the findings, those analyses. Okay. So if sometimes what happened last year, and probably is going to happen the same today, is that your repo might not get synchronized for various reasons. And one of those reasons usually is that the program kind of doesn't want to overwrite your files. So remember, every time you shut down your environments, you say you go to log out here, and then you wait a couple hours, the system that we built will try to resynchronize everything. But if you have modified something inside, and I don't think it's a reproducible error, is like a random thing that happens. Sometimes it doesn't synchronize the new repo information into your environment. So these are some steps that I would suggest you follow to get to delete all the contents of the repo that you have here. So the S4 lectures, you can delete all of these with this command, but you have to be careful to put the full path. And then you restart the server, you go to the top, and then you click stop by server, and then you restart it, it will resynchronize everything. So also today, I think yesterday we tried to create Zoom meetings. Well, we tried to open the Zoom meeting so that you can participate. Daniel? Yes.
Can you just summarize why we would need to refresh and the repro? Why would that need to happen?
Yeah, for example, this could be like something that's maybe happened to some of you. So I updated this notebook yesterday, like 9 hours ago, for example. So for some of you, maybe it doesn't show that it was updated like 9 hours ago because the system failed to update that. And it might not, I mean, it happened last year. We don't know exactly why. So if that's happening, and that's happening consistently, that you're not seeing the new content that we're putting on the folder, on the repo, then we will suggest to just get rid of this subfolder and ask the system to do a complete download of everything.
Okay, thank you.
You're welcome.
I am seeing those, so maybe it's not the same problem as you're having last year. Fingers crossed.
Yes, maybe we'll learn in a year. Yeah, so we're not sure why it happened. Okay, so so if you don't have groups yet, I'll create a discussion session probably after this lecture, where I will have breakout rooms for the different projects, and also breakout room for people that are looking for projects to discuss, and maybe give you like 15-20 minutes to discuss that, and maybe we'll move around the rooms to see how things are going. So that's one way. We want to just push you to think about a project. Again, this summer school is, we're talking the first week, and I'm kind of the main face today, but the summer school is really driven by you and your projects and the mentors. So the Zoom meeting is will be open in the afternoon. I think yesterday we had some technical difficulties where Zoom, I think, closes automatically after inactivity. So I think we'll think of a way of keeping it updated. Maybe a dummy click every 39 minutes, that will do it. So now I didn't, well, this is my fault. I didn't post-process the videos from yesterday. It was taking hours for iMovie to create them. So I need to think of a better, smarter way of doing it. So I hope to post yesterday's videos today. And if I learn anything from that process, upload the videos from later today. Well, I guess in the Eastern time. And they will be available here. So are there any questions? Okay, so I'm going to move on to the first set of slides. Close that. And then here. All right. So the way that this lecture today will work is that I'll have slides like this, like usual slides like PowerPoint, but then there are notebooks that have the code, and I will go through the notebook myself, but if you want, you can open the notebook now, and if you have a big enough workspace, maybe a monitor or 2 monitors, if you're lucky enough, you can be running the notebook that is a companion to this set of slides. So these are the slides, and this is the notebook, and the notebook goes through what I will be talking about in the slides. So that's one way of doing it. Okay, so Python, I'm kind of experienced, or I've been around long enough to remember the times where programming in scientific computing was basically you either use MATLAB or some specialized combination of packages in C or something like that. And it was generally difficult to, let's say if there was a new method invented, or to plot something or to load data from exotic data sources, it was relatively difficult to get that. But Python came along and introduced whole ecosystem of software that allowed you to not just program, but also manipulate array data. That would be NumPy, use scientific libraries and functions to compute, fundamental like matrix operations, eigenvalue decomposition, if that sounds vaguely familiar. For plotting, for interacting with the environment, for doing symbolic computation of, Mathematica or Maple, those are systems that are sort of symbolic mathematics. So there is a version of that in Python. And for loading data and manipulating tabular data, pandas is the go-to package for that. So Python is this very rich environment for doing scientific computation. It's not the only one. R is also very useful and very powerful, but Python, we'll be using Python in this summer school. So Python is composed of packages. So when you download Python, it usually comes with many packages for all kinds of stuff. And when you download a distribution such as Anaconda, which I talked briefly yesterday, it comes with additional packages, like many megabytes of packages that you can use. So it comes with NumPy, pandas. The environment that we set up for you here has many packages. So it's not just the Anaconda distribution, but it has additional packages such as Spark and others for loading big data sets. So NumPy is the first library that we'll look at. And yesterday we saw how to create lists in Python. So those were like built in into the programming language. But the problem with vanilla lists is that they don't understand like basic operations. So let me do the following. I'm gonna here. How do I here? Current here. All right. Okay. So let's say in Python, if we create a list and then we multiply that list by 4, it doesn't do what you would expect. Like if this was a vector, you would expect each entry to be multiplied by 4. What Python does, the vanilla list, it will repeat the list 4 times, which is really strange behavior. But that's what they thought was useful when they designed Python. So NumPy kind of solves that by saying, okay, we're going to define an object that is a multi-dimensional matrix or array, and we'll define all these standard operations that we know from linear algebra to manipulate those arrays. So the way to do it, and the way to work with any package, you do import the name of the package, and you can rename that import. So you can say, I'm going to rename the numpy package as np, and that's a really standard name for numpy. And you can create arrays in multiple ways from Python packages. You can generate them from random numbers, or other libraries generate numpy arrays as well. So here I'm going to create an array from a vanilla numpy, from a vanilla Python list, or I can use this generator here that says, okay, create a matrix of 3 by 3 with zeros. Okay. Now, NumPy doesn't allow you to store multiple data types. So here in Python, I can do that. I can create a list where I have 2 integers and then a string. That's no problem. But if you do that in Python, sorry, NumPy, it will basically convert everything into string, because with a string you can store anything. So, but it won't be a number. So you can't multiply this array by a number. It won't work. It will complain. So you have to be careful about that. You can store only one data type.
Does it give you any error that notifies you that it's done that, or is that what the U21 is?
It doesn't give you an error. It just says the type of the array is U21, so it's like a integer of maximum length 21 characters. I think that's what this means, but it doesn't tell you anything. Now let me try live. If I multiply this, what happens? Okay, so it doesn't work because these are strings, so it cannot multiply. But if this was numbers, I will be able to multiply them because it understands the multiply element-wise. Now, what's really cool, I think, and useful is you can access the elements of the arrays in a similar fashion as you will do in linear algebra. Sometimes you want to say, I want to access the ith row and the jth column, and it understands that notation. And it also understands the notation that we saw yesterday. So we will have like, okay, we want to take a slice of a multidimensional array. So here I'm going to create 2 arrays. One is a vector. The other one is a matrix, and I can get from the vector 1 element and from or multiple elements, similar to what we saw yesterday with arrays. If it's a matrix, it's a little bit more. It's a little bit more, I guess, unintuitive in the sense that here I will get the first, not element, but really the first row of this matrix. So this 0 is, you will get this list here. So if I execute that, I will get the first row. And if I do the slicing again, I will get sets of rows. So here I'm getting a set of rows from the matrix. And I can do more sophisticated stuff because I know that I have not just rows, but I have columns. So with this, I will get these rows. And additionally, I will only get the first 2 columns. Now, matrix operations work with no problem. So if you want to do any operation with this, you can just do them, and it understands. NumPy will understand what you want to do. So if you want to transpose a matrix, then you use the .t I guess function or access, or I don't know the proper name of it, but this allows you to do that operation. And if you multiply 2 by the matrix, it will understand that you want to multiply, not repeat. And if you want to add, so these are all standard operations from linear algebra. It understands that you want to add 4 to each of the elements in the matrix. So you can also do matrix multiplication. So in the past, you would do it like this. You would do a dot product between matrices to do the matrix multiplication. But I think since a couple of versions ago, you can use the @ command. or the at symbol to signify notation. So this is the same as saying A multiplied by B. And oops, here. And you have inverted inversion of matrices. So the inversion of inversion should be the same metric. So this is just showing that it's working properly, although there are some approximation errors. Now, for some of the stuff that happens in the science of science, especially you see it a lot in network science, where they create, let's say a citation network that has certain characteristics similar to a real citation network, but you randomize some things. So, for example, if you want to see if there are influences on the age of someone on the productivity in the citation network, you can say, okay, I'm going to create a random citation network where I move when something is published, but I maintain the citation structure. So it's the same citation structure, but when they happen, it's different. And then you run like an algorithm like PageRank or something like that, and you see the changes in the influence of each of the papers. So if you don't know what I'm talking about, that's fine. But the basic idea is that you want to use some sort of randomness in the system to see if what you're after is really part of just the randomness of the system, or is part of a signal. So is the career stage of someone really influencing the PageRank, as in the example of citation networks, or it's just part of how the network works. So if you're familiar with statistical learning or just statistics, like I guess linear regression, for example, we don't really do that. We have all these tests to do that. So statistical test, chi-square test, ANOVA, we do that, and that's kind of hiding what's happening. And it's really beautiful sometimes to create null models based on random number generators, because you really get to understand what's happening underneath your hypothesis. So Python and NumPy allows you to create random numbers with different distributions. So and there are many random numbers generators, and if you don't know these things, that's totally fine. I don't know half of this distribution. So you have, the typical normal distribution, but you have multinomial, log normal, etc. So Amaral, for example, who is a researcher in Northwestern in science of science, and he was a mentor last year. He has this paper, and I'm not endorsing any paper here, but he has this very interesting paper that shows that basically you can model citation distributions of almost any field by a log normal distribution. So it's basically a normal distribution, normal variable, and then you take so what is it? Let's see. I'm gonna cheat. Log normal. Distribution. Okay, the logarithm. Okay, so this you take. So this is the citations. So there is a random variable. Sorry, these are the citations. So if you take the log of the citations, that's normally distributed. That's the basic idea. So anyways, the idea of that paper was that you can represent any field, not just by the data. You don't need to look at the data, basically. So it's a really nice result. You just need to look at what is the mean and standard deviation of its log normal distribution. So that's just one example. And you can generate random numbers with that. So this is the way to do it. You do, well, in this case, this is a normal uniform distribution sample. And you do it like that. You can create a normal distribution with mean 5 and standard deviation 2. And that's how you would do it. Okay, so I'm going to move a little bit quicker here because To be honest, we don't usually use vanilla Python numpy unless you're doing like more hardcore simulations. We usually use, at least if you start with something like pandas that allows you to load data and do some analysis. So I'm gonna move a little bit quicker here. So let's say we have a matrix A3. Here's a matrix of 3 by 5. You have many operations that work on matrix. So here I'm taking the mean of all the elements, but sometimes you might want to take the mean across rows. So this will mean, okay, we'll take the mean, but I will do it across the axis 0. And axis 0 is the first dimension of the matrix, which is in matrix parlance, that's the rows. So this will create 5, sorry. So it will create, it will do the meaning, the mean, the averaging across this dimension. So it's the opposite of what I was saying. So it will create a result where you have the same number of columns as the original matrix. And there are many operations that you can do with matrices. So with this little code, you can get to all the operations that are inside a matrix. So you can take the conjugate, the dot products, etc. You can flatten the matrix. Now you can chain operations, of course, because this will return a transpose. Then you can take the mean of that transpose, and then you can sum the result of that mean. I will skip that. Sometimes you want to select elements. So let's see if I need to execute. So I need to execute that to get A4. So if you do something like this, it will do this operation across all the elements. So let me show A4 again. So this is saying this operation will create a new matrix where it will be true if the element is greater than 0.5. So there are a couple of them. So this first middle ones, these 3 middle ones are all greater than 5, but all the rest are less than 0.5. So what you can do, you can say, okay, give me so you can pass a mask to the matrix. And this will basically say, okay, give me all the elements of the matrix that are greater than 0.5. And that will show you that. You could do more sophisticated stuff. You can say, okay, I'm going to now select rows. And the way to select rows is to just pass a vector of length 3, which is a Boolean vector, a Boolean mask. So I want to select rows for which this is true. So in this case, I'm saying, okay, give me the rows for which the summation of all the columns is greater than 2. There's only one of them. So the middle one happens to be that. So if I do the selection, if I pass that vector, if I pass this vector to the selection of rows, it will return what I want. It will return only that row. Okay, I'm gonna skip this. So there are many operations that are so let's say here, if I do a plus 3, it will let you understand that it's adding the element 3 to each of the elements. But I can do the same with this operation. So I'm just saying use the function addition and apply to this argument and this argument, it will do what you want. So there are many functions such as this. So one of them is, for example, the sign function. So this will do the sign of each of the entries in A, assuming that they are in radians. And you can do other things like the exponential of each of the entries, etc. Okay. Now, one of the problems with NumPy is that let's say you're loading data and you have data about citations, about H indices, about career stage, you will have like several columns. But in NumPy, you don't really have the names of those columns. So you have to kind of remember every time, okay, this column represents the H index, this column represents the age, this column, so you have to remember the names. So pandas solve that by having names for the columns and also names for the rows, but we don't usually use that too much. So you can say you have a lot more metadata about your data. So pandas is really a collection of columns, and those columns are called series, and they have names, and also they have different types. So if you do, for example, natural language processing, a column could be text of a citation context, and another column could be a number, and another column maybe is a matrix. So it doesn't care, pandas, whatever you store in each of the cells. Also, pandas has very good functionality for reading from multiple sources. And Lijian, in his demo yesterday, he was showing how to load from OpenAlex, a small sample that we have in the cluster about OpenAlex. So the usual standard name that people put to pandas is PD. And so let's go there. Let's go to the notebook. So I'm going to load pandas, numpy. So you can create a pandas immediately by passing a matrix. So this is a matrix that I created from numpy. So it has 100 rows. Imagine that you have 100 observations with 5 variables, 5 columns. So you can pass that matrix to the object, to the class data frame, and it will create a pandas data frame. And it also has this nice way of displaying it, the data. So it doesn't display all the rows, and if you have many columns, it also will truncate what is it showing you. Now the rows and columns have names. In this case, because I didn't pass anything, the names are going to be just numbers, so the indices of the rows and columns. But you can do something like this. Okay, so you can create 2 columns, and you can say, okay, I'm going to create a data frame where the first column is going to be named X, and the second is going to be named Y, and I can put the data that I want there. And then you can access the columns by using this notation, which is similar to numpy and is similar to vanilla lists. Okay, let me quickly check something. So if there are any questions, I know that I'm going fast through this. I hope you can review them at your own pace. Some point. So you can access the columns. Sometimes you can ask multiple columns at the same time. So here I'm asking for 2 columns, and I'm asking in a certain order. So the default order of this data frame was X first and then Y. But here I'm saying, okay, give me Y first and X, and then X. It also understands the operations of linear algebra. So you can multiply numbers, you can transpose, etc.
I have a quick question. This is all really interesting. I feel like I'm finally starting to tune into the kind of interoperability, I guess, if that's the right word, of all these different programs. But I just was wondering, what's an example of a way that you've implemented these tools for a research purpose, just for context?
Yeah, so if you go to Lijian's code from yesterday, and I think I have the same for today. So OpenAlex. So many times you have data that have about something like this. You have like public authors in this case, and they have all kinds of data types. So this is like a string, right? But sometimes you have numbers. So this row represents one author in OpenAlex, right? So sometimes you want to do operations with this or extract only one thing, which is how many times someone has been cited, how many papers they have created, and you can select that and use that. So in this case, authors is a pandas data frame, and you can manipulate it in any way you want. And so that's an example.
Thank you.
And if you do manipulations and processing, then you can save that. And I don't think we can show that, but you can say, okay, I'm going to do some summary statistics or something like that, and I will save that into a CSV file and then share it. Okay, so you can also store all kinds of data. So each columns could be of different types, as I showed in the previous example, but there are many data types that are related to times. And that's a really powerful construct of pandas. So you can have a column that represents a time, sorry. And that's really, really powerful, but we don't use it a lot in Science of Science. Okay, so I'm going to skip over this. So please, I guess I will look at, so let's see, df here. So we'll create a data frame called df. Okay, so I have a data frame called df where I have three columns. And sometimes you want to apply functions to each of the elements of each of the columns. So this, you can use the apply method, or you can use the apply map, which would apply this function to each of the elements of the matrix. So here I will create a kind of a Boolean matrix or a 0-1 matrix where you know, if it's greater than 0, it will be a 1. If it's less than 0, it will be a 0. Okay, so if you're familiar with SQL, you can join matrices or data frames as well. So here I'm creating 2 data frames where I have, you know, the same key, and I can join them using that column. Here the result is 4 because I have 4 combinations of those. I can group them. So here I have a data frame. I have numbers, and I can say I can group by by column A. So I will create 2 entries and take the sum of the entries that are numbers. So I will take the sum of everything that is in C for the rows for which A is bar, and the same it will do for the column B.
And B is not there because it's not a number, is that right?
Right, exactly. It's not here.
It's a string. Okay.
It's a string, yes. Okay, so so I have an example here. So let me skip. I just want to make sure. Okay, so I have an example here of mag. I know that mag is you know, somewhere, but it's not what. So let me see if this actually, if it works. Okay, it works. So I have a sample of papers from mag, the Microsoft Academic Graph, and it's available in your space as well. So it's in datasets S4, mag, CSV. It would be great if someone translates this into OpenAlex, which is also available here. Okay, so here I have papers. So in mag, you have, this was the data or that you had on the papers. They have even papers in Spanish and German, I think. So they just scraped the web, so it didn't matter the language. Okay, so these are papers. These are the columns that I have for each of the papers. These are the types for each of them. And then I can do something like, okay, describe the table, and I can use this. If you're familiar with R, in R, there's a command called summary that will give you something similar to this. So you can see, you know, how many entries there are, what is the mean, the standard deviation, etc. Just a quick glance of things. So here I'm going to get, you know, the paper titles, etc. So let me keep moving. You can do, you know, operations with this. So you can say, okay, I'm going to sort the papers by citation count in ascending order, and then I want to only get the paper title and the citation count, and then I only want to get the first 20 of those. So these are like the top 20 papers that I have in this little data set, ordered by the most cited first. Okay, so this seemed all to be from molecular things and then biology and things like that. I think. Don't
What's
quote
happening
me.
with the formatting in that cell? Up a little bit, please. Yeah, what's going on in
yeah.
here?
So if here what's happening is that sometimes you have lines. So if I do this like in one line, it might look ugly. Sometimes I don't like it like this. So what I do, I try to split it in multiple lines. So let's say I want to take papers and sort them. But if I execute this, it won't work because it won't understand what's happening. So if you do backslash, sorry, it will understand that you're continuing the command below. Okay, that's one thing. And the other thing that I did is, okay, if you have parentheses, you can break the lines and it won't complain. So I can do something like this and it doesn't matter because I have parentheses. And I don't know why it was like that, but but I had so many spaces. But usually you do that, especially if you have multiple chain of things. So if you do like, let's say, a group by, then blah, 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 and then other things, you might want to chain them like this. Just visually, it's more appealing.
So after a period, you need the slash, but inside of parentheses, you can do whatever you want.
If you want to continue a command below in a different line, you need the backslash. It doesn't matter if it's period. So I could do it here. Okay, so imagine I want to continue this below. I can do backslash and do it like this. And the same here. So I can do this. All right, so so I can get this is the same as numpy. I can get the papers for which this is true. So these are papers that have more than 100 citations. So this is getting all the rows for which this is true. And you can do it with query as well. Going back to the person who was asking before. Sorry, I didn't catch your name. Sharing screen with Zoom is not the greatest. I don't see anybody. So here I can say, okay, give me the rows for which this is true. The column is, the citation is between 100 and 150. Okay, I want to get to plotting. Am I supposed to be talking about plotting now? I think so. Okay, so blah, blah, blah. All right, visualization. So for visualization, we use a package that it's not the greatest package ever for visualization, but it's what we got in Python. There are many other alternatives that I try to improve, but we use a package called matplotlib. And if you know MATLAB, this will be familiar to you, but it's like Python tried to borrow many of the functionality from MATLAB. So you do that, and with that you import a package that allows you to do everything that you do in MATLAB. So I will use the classic format. So here I have a matrix. I don't have a matrix. Okay, here. So what I will, as a test, I will create a vector that will go from 0 to 10. And it will, the length will be 100. So I will just plot them. And what's interesting is that it's showing it like this and stop interaction. I don't know what's going on. Maybe this is new functionality. Okay, I wasn't familiar with this. So let's see. Oh, if you do this, I was cleverer last year. So if you do this, you will create like interactive plots embedded in the notebooks. So you can do, you can explore, move around the plots. So that's interesting. All right, you can combine plots. So if you do two plots, you can use subplot, and then other things, multiple lines, different types of lines. Sorry. Okay, so as I was saying, matplotlib is relatively simple. So there is this new package called, let me go back. It's called Seaborn that has, I guess it's not new anymore, but it was new, 5-10 years ago. That allows you to do plots that are relatively standard, and it does it very easily. So here, for example, with Seaborn, you can do a pair plot where you have, Iris is this very famous data set of different kinds of flowers, I believe. And you can do something like this, where the diagonal is the histogram of the different types of flowers. So this is the sepal length of the different flowers. You have three different flowers. And in the diagonal, in the off diagonal, you have the scatter plot of the variables. So this is like a standard exploratory space plot that you will do. Okay, so I had a little activity here, and the idea is I want you to create a line with matplotlib where it shows the trend of number of papers between 2000 and 2010. Okay, so let's have the papers, have the year. And okay, so if you do this, it will give you the counts. And then, well, I guess I have the solution here. So that's good. So it's missing some stuff. No, it's doing it. Okay, so this will plot the number of papers per year from 2001 to 2010. And I want you to do the same with, but now separated by type of document. So there is a column called type of document, and you have to discover which one. So I want you to reproduce this plot. So it's the same idea, but instead of being across all fields, is across type of documents. So so let's do that. Now, I'll pause the recording now. But let's see first. Okay, so I don't know if anybody worked on this. If not, that's fine. I don't even know the solution, but I think you're supposed to group it first. So if I read the papers, okay, nothing happens. So I have papers. And then if I have group by, okay, this is excellent time to embarrass myself. Group by, what's the column? Let's see.
You can simply use count plot, I think, maybe, if you want.
Okay, what is it? Multiple plots?
Yeah, no, I think you can use the count plot, but it just doesn't give you that scatter form, that thing, but it's actually give you bar plots for maybe 2000, 2010, 2020, and maybe it's good to.
I see. Oh, I have to group by two things. Okay, so I have to group by year. Okay, and then okay, never mind. This is all just I guess we need to sort values. Right. Okay, homework for everybody, including me. I forgot how to do this. And if someone was yes, I think she was saying the answer. But okay, let's move. Let's stop embarrassing. I'll stop embarrassing myself, and let's move on to the next topic. And now today there are like many notebooks here, and this is just I'm trying to be very introductory, and it's very hard